Hi everyone, in this little video I'm going to act out for you attenuation as a control of the tryptophan operon. And so this piece of paper represents the transcript of the leader sequence in the tryptophan operon. So the leader sequence is between the promoter and the operator and the coding part of the DNA that's going to give us the biosynthesis genes, right? So over here we would have the promoter, then we'd have the operator. So the operator is where the repressor is going to bind for the negative transcriptional regulation. And then we have this leader region. And so the first part of the leader region is going to be translated into the leader peptide. So for that we've got the Shine-Dalgarno sequence and the start codon. And then here's region 1. And region 1 has the 2 tryptophan codons. And here's the stop codon. And then here's region 2, and region 3, region 4, the poly-U sequence, and then back here starts the rest of the trip operon. Okay, so this leader part's really long. And so what's going to happen is the RNA polymerase is going to come on to the promoter, and it's going to come down and start doing the transcription. So we're making transcript right about here, the ribosome. I'm using the clear ribosome, so hopefully you guys can see it. The ribosome comes on and it recognizes the Shine-Dalgarno sequence and the start codon. So the ribosome comes on, and then we have, I know this is not really the way it is, but I'm just going to move the transcript. So then we have transcription and translation simultaneously. Okay? So the ribosome is going along, it's making protein. If there's plenty of tryptophan, then when the ribosome comes to these 2 tryptophan codons, it's just going to go right on past. And then it comes to the stop codon and it's going to stop. But when the ribosome stops at the stop codon, it covers up, you can see, part of region 1 and part of region 2. Okay. So consequently, we're going to scooch these down. As the RNA polymerase goes down and transcribes region 3 and region 4, then region 3 and region 4 will immediately form the stem loop as soon as they're both transcribed, because they have the complementary inverted repeats. Okay? So then the RNA polymerase pauses after the stem loop, and then what do we have here? The poly-U. And so the poly-U is not strong enough to hold the transcript onto the DNA, because there's just the 2 hydrogen bonds between the adenine and the uracil. So the transcript is going to fall off, the RNA polymerase will detach, and we will not transcribe the rest of the tryptophan operon. This is attenuation, when transcription starts, but it stops before we get to the actual coding part of the operon. Okay? Hopefully that makes sense. The other thing that can happen is if we don't have enough tryptophan. Okay? So we start transcription the same way. So we're starting transcription, and then the ribosome comes on, recognizes the ribosome binding sequence and the start codon, and then we get more transcription. Then the ribosome comes to these 2 tryptophan codons. If there's not enough tryptophan, then the ribosome stalls here. You'll remember that when there's nothing to come into the A site, possibly because it's the stop codon, but possibly because we don't have any charged tRNAs that match to go in there. So if we're short on tryptophan, we have no tryptophan tRNA, so the ribosome just sits here waiting for tryptophan tRNA, which is probably not going to come. Meanwhile, the RNA polymerase goes ahead and moves down. So it transcribes region 2, and it transcribes region 3. As soon as the RNA polymerase is past region 2 and region 3, they also are complementary to each other. So they will immediately stem loop. Okay? So once region 2 and region 3 have stem looped, the RNA polymerase pauses. It always pauses after the stem loop. But it doesn't detach the transcript from the DNA because there's no poly U here. Rather, the RNA polymerase just keeps going past the poly U because the poly U does not detach the transcript unless the poly U is preceded by a stem loop. Okay, so the RNA polymerase just goes on past the poly U and will transcribe, the rest of the codon, the rest of the operon, sorry. And then we will get production of more tryptophan, which we obviously desperately need since the ribosome stalled at the tryptophan codons in region 1. All right, does this make sense to you? Hopefully this makes sense to you. I'm going to try something else as well. So if this does not make sense to you, try the next video.